Hello everyone, here are all the solutions to yesterday's worksheet 1 through 10, the second worksheet on adding and subtracting rational expressions. Go ahead and pause the video just to compare all these answers to yours and then resume playing so you could see as I go through each problem step by step. All right, so for number 1, we're adding these two fractions. So again, like I mentioned in our notes from Monday, I want to make two blank fractions. We're adding them. Figure out the LCD. Well, they're both monomials, and x can go into x squared. Any number can go into the number if we square it, like a 5 goes into 25. So we're going to use x squared for our LCD. So x got multiplied by x to get x squared, so 1 gets multiplied by x. So x over x squared is an equivalent fraction to 1 over x. The second fraction, the 5 is going to stay because the x squared was already there. We didn't multiply by anything new. So we changed or adjusted our numerators. Now we're going to make one big fraction, keep our denominator, and simply add the numerators together. We get x plus 5. And there's nothing else we can do with that. All right, looking at number 2, our denominators are still monomials, but they have two parts to them. There's an a and a b for each monomial here. So we just look at the a's. So this single a can go into a squared, so we're going to need an a squared for both LCDs. And then b can go into b cubed, so we use the larger of the two exponents there. So our LCD is a squared b cubed. Now carefully we have to figure out what 8 needs to get multiplied by. So the a squared was already there. We had one b, we multiplied by 2 more b's, so we have to multiply by a b squared. So we're going to get 8b squared. So we multiplied our denominator by b squared and our numerator by b squared. The 6 will have to get multiplied. We already had the b cubed, all 3 b's were there, but we had an a and we turned it into an a squared, so we have to multiply by an a. So 6 gets multiplied by an a. Then we make one big fraction. Keep our denominator, just go straight across here. We get 8b squared minus 6a. Now we would still try to factor to see if anything can divide out, but based on the answer is this right here, so no, nothing will divide out. But we could still just factor out a 2, then we would be left with a 4b squared minus 3a over a squared b cubed. And there's no number out in front here, but we still just had to try. But we could leave our answer just like this format or this here if you decided to factor out the 2. Number 3, again, our denominators are just monomials. What's nice here is that they're just numbers. So again, I'm going to make 2 blank fractions. 3 goes into 6, so our LCD is 6. Now the 3 got multiplied by 2 to get 6, so I need to multiply the numerator by 2. And the second numerator doesn't get multiplied by anything because the 6 was already there. However, because I am subtracting, I want to put it in parentheses. I'm subtracting a binomial, so I need to subtract both terms. So now we're going to make one big fraction. I'm going to write it out this way just to make sure we don't make any little mistakes here. I'm just bringing down all parts of the numerator without distributing just yet. Now I'll distribute, so we'll get a 2a plus 6 as we distribute here. And I want to distribute the minus sign or a negative sign here, so we're going to get a minus 6 and then a plus a. So carefully take a look at that step. Next we want to combine our like terms up top here. So the 6's are going to cancel. Then we're going to get a 3a over 6. Now that 3 and 6 can simplify. 3 becomes a 1, 6 becomes a 2, so we get a over 2 is our final answer. Right, 4 is very similar. We still have monomial denominators. Now I'm going to take a look separately at the 3 and the 9. 3 can go into 9, so I need a 9 for each denominator. And as we were kind of doing this before, x goes into x squared, so I would need an x squared with each one. So 9x squared is my LCD. So what did 3x squared get multiplied by to give us a 9x squared? That got multiplied by a 3. So it's like we're saying times 3 times 3. So we have to do 3 times the quantity 2x minus 3. 9x, to get a 9x squared, we had to multiply by x. We do it times x times x. So we're going to say x times the quantity 3x plus 3. Now we're going to make one big fraction. Now here, because it's a plus sign, I don't have to worry about distributing any negatives, so we could go ahead and distribute in this step as we bring it down. So we're going to get a 6x minus 9. Over here I want to distribute an x, so we'll get a plus 3x squared plus 3x up top. Combine our like terms. I want to write the 3x squared first. 6x plus 3x will give us a 9x minus a 9 over 9x squared. Now there is a GCF up top of a 3, so let's try. Let's see what happens if we do this. We're going to factor out a 3. We're going to have an x squared plus 3x minus 3 left over. And because our denominator is a monomial, this 3 and this 9 can be simplified. So 3 goes into itself once, into 9 3 times. So now I'm left with up top x squared plus 3x minus 3 over a 3x squared. All right, when we take a look at number 5, we have an x minus 1 and an x plus 1 as our denominators. These are not opposites. Opposites would be an x minus 1 and a 1 minus x. And there's no way to factor these, so our LCD is just both of them together. They have nothing in common, so we simply multiply them both together. And we'll adjust our numerators. So the x minus 1 was already here. We had multiplied by an x plus 1, so that 5 will get multiplied by an x plus 1. And just the opposite here, this 5 will get multiplied by an x minus 1 because the x plus 1 was already there. Again, we're going to make one big fraction because that's the goal of adding or subtracting fractions, to make one fraction. Keep our denominator. And because we're adding again, I can just go ahead and distribute as I move into my next step. So we're going to have 5x plus 5, and over here plus 5x minus 5. Combining our like terms, the constant 5's cancel. We'll get a 10x over our denominator. And we can't do anything else. The 10x is a monomial. The two factors in our denominator are binomials. All right, as we move into number 6, I'm going to rewrite this first because I want to factor the first denominator. So this will factor into an x minus 5 times a quantity x plus 5. Now, if we notice this x minus 5 and this 5 minus x are opposites. So if you recall what we did in class on Monday, 5 minus x is the same as the opposite of x minus 5. And now I can take these two negatives and turn it into a plus. So now this becomes 3x over x minus 5 times x plus 5 plus 4, because minus a negative will become a positive. And I could just move this negative out in front. 4 over x minus 5. And now it's a lot easier to determine the LCD. So my LCD, x minus 5 can go into this because they already have an x minus 5 in common. So my LCD is both of these, x minus 5, x plus 5. So the 3x will just stay because it already had both factors in its denominator. The 4 will have to get multiplied by the x plus 5. So we're going to make one big fraction now. 3x will just drop down. We can, because this is a plus sign, we could distribute a positive 4, so we'll get a plus 4x plus 20. Combine the x terms, so this is where I'm coming up with 7x plus 20 over the LCD. Right, 7 and 8 are very similar. We see trinomials in our denominators, so the very first thing we want to do is rewrite them and factor each denominator, just so we can see what they have in common. So the first denominator is going to factor into, say, x minus 5, x plus 2. We'll get our x squared first. 2x on the outside minus 5x on the inside will give us our minus 3x, and negative 5 times positive 2 is our negative 10. Our second denominator will factor into an x plus 7 and an x plus 2, because 2x and 7x outside and inside will give us our 9x, 7 times positive 2 will give us our 14. So now the LCD, they have an x plus 2 in common, but then I also need an x minus 5 and an x plus 7. So we'll say x minus 5, x plus 2, and x plus 7 is going to be the LCD. We could write these in any order, it doesn't matter. What's nice is that the numerators are 1, so I really don't have to write the 1 here. So this numerator, though, whatever number it happens to be or whatever's up there, would have to get multiplied by whatever wasn't there. So it already had the x minus 5, it already had the x plus 2. We multiplied this denominator by an x plus 7, so the 1 has to get multiplied by an x plus 7. This one over here would have to get multiplied by an x minus 5 because it already had the x plus 7 and x plus 2. And again, those ones don't change anything. I just really have an x plus 7 and an x minus 5. But now we want to make one big fraction, keep our denominator. Then we have x plus 7 plus x minus 5. Combine our like terms, we'll get a 2x. And we have a 7 minus a 5, so we get a plus 2 over the LCD. Now, if we were to factor our numerator, it would be a 2 and an x plus 1, but that wouldn't, nothing would divide out here, so we could just leave our answer like this. All right, very similar for number 8, but now we have more up top in our numerator than just a 1. So just as I started the last problem, I want to start by factoring our denominators. So this denominator will factor into an x plus 3 times the quantity x plus 1. We'll get a 3x and a 1x on the outside and inside to give us our 4x and then a positive 3 at the end. Over here, we'll have an x minus 4 and an x plus 1. 1x minus 4x will give us our minus 3x in the middle. So now our LCD, what do they have in common? They have an x plus 1 in common. So just like the last problem, I also need an x plus 3 and an x minus 4. So we'll say x plus 3, x plus 1, x minus 4 for both of them. But now because 3x plus 1 is a binomial, I need to put it in parentheses. The denominator already had the x plus 3 and the x plus 1. We needed to multiply it by the x minus 4, so I need to multiply the numerator here by x minus 4. Next, I'll put the x plus 6 in parentheses. The x minus 4 and x plus 1, they were both already there. I need to multiply by the x plus 3. Now also, because we're subtracting, whatever we get here, I need to subtract. So I need to put that whole quantity in brackets. Now I'm going to make one big fraction, keep our denominator. So let's go ahead and distribute here. We're going to get 3x times x is 3x squared. 3x times a negative 4 is a minus 12x. 1 times x is plus 1x. And 1 times negative 4 is minus 4. Then we're going to subtract as we distribute here. X times x will be x squared. Here, because there's no leading coefficients other than 1, I'm just going to do the outside and inside terms together. We'll get a 3x plus a 6x, so we'll get 9x, and then plus 18. Now as I go to combine like terms here, we'll have a 3x squared. We'll get a minus 11x minus 4, and then I'll distribute the minus sign here. So we'll get a minus x squared minus 9x minus 18. And still combining like terms, 3x squared minus x squared is a 2x squared. Negative 11x minus 9x will give us a minus 20x. And negative 4 minus 18 is a negative 22. All right, we're still not done yet. If you notice the numerator, there's a 2 in common, so we could factor a 2 out. That'll leave us with x squared minus 10x minus 11. Still not done yet. We're going to try to factor x squared minus 10x minus 11. And that will actually factor into an x minus 11 and an x plus 1. This will give us negative 11x on the inside plus 1x on the outside will give us our negative 10x on the inside here. And now if you notice, we have some common factors of the x plus 1. But we didn't know until we tried to factor. So now the x plus 1's divide out. And we're left with 2 times the quantity x minus 11 over x plus 3 times x minus 4. So that was definitely a lengthy problem. All right, 2 more to go. Now for number 9, I can factor this third denominator. So that's what I want to do, is just rewrite everything right now, factoring only that third denominator. Now, even though we're adding 3 fractions, or adding and then subtracting, but we have a total of 3 fractions, the rules still don't change. We just have one more fraction. And z squared minus y squared, that's a difference of squares. That's going to factor into a z minus y and a z plus y. So there's a couple ways we could work this out. Notice y minus z and then the z minus y are opposites. So we have our choice of what we want to change. I think it might be easier to change this last one here. So we're going to say z minus y is the opposite of y minus z. So that's what I want to fill in its place. So we're going to have 3 over y minus z plus 3 over y plus z. And then we're going to have minus 6z. And this first factor I'm going to rewrite as the opposite of y minus z and then z plus y. So now if I subtract a negative, so I could put these two negatives together, and now I get 3 over y minus z plus 3 over y plus z, and then minus the negative becomes plus 6z, and now I have this over y minus z. And z plus y and y plus z are the same thing. I'm just going to switch the order so all of our y's go first. So they're not opposites, but they're exactly the same because everything's positive. So I needed to do all that to help us figure out the LCD. So if you notice, the first denominator is a y minus z, second is a y plus z, the third has both of them, so our LCD is going to be both of them. So I'm going to make 3 blank fractions in this case. All of them are going to have the LCD of y minus z, y plus z. Then we'll adjust our numerators. So this 3 already had the y minus z. We need to multiply it by the y plus z. The second fraction already had the y plus z, so we need to take that 3 and multiply it by y minus z. And the 6z already had both factors in its denominator, so we don't have to do anything to it. Now we make one big fraction over our LCD. Distribute, everything's positive now, which is nice. So we'll get a 3y plus 3z plus 3y minus 3z and then plus 6z. Combine our like terms. Notice the 3z's are going to cancel. So we'll get a 6y. I have the 2 3y's together, 6y plus 6z over LCD. You think we're done? We could factor out a 6 from the numerator, so we're not done yet. What's going to be left? Y plus z, which is nice. It's going to cross out with the bottom y plus z. So now we can cross those out. We have 6 over y minus z. So I had the other answer of a negative 6 over z minus y, just in case we go back to the beginning and if we replace the first one with the opposite of z minus y, then we would have to move that negative out in front. But all we did was we really just took the opposite of both. So if we took the opposite of our denominator here, we'd have to take the opposite of our numerator. All right, and our last one, another 3 fractions. Nothing to factor here, so all we have to do is first determine our LCD. Well, m can go into m squared, so I need an m squared for all 3 of these. And then the other factor is m plus 1. So my LCD is m squared times m plus 1. So this m needs to get multiplied by another m to get m squared and the m plus 1. So this 1 needs to get multiplied by another m and then the m plus 1. The 2 already had the m squared, so it needs to get multiplied just by the m plus 1. And the last 2, the m plus 1 is already there, so it needs to get multiplied by m squared. Now we'll make one big fraction. Here's our LCD. I really don't need the 1. I'm just going to distribute the m. So we're going to get an m squared plus m. Here I'm really distributing a negative 2. So for right now, I'm just going to write it like this so we don't make any mistakes with our signs. And then plus 2m squared. So now up top, we'll have m squared plus m minus 2m minus 2 plus 2m squared over the LCD. Let's combine our like terms. 2m squared plus m squared is 3m squared. M minus 2m is a minus m. And then we have our minus 2. Now let's see if we could just off to the side here, let's see if we could factor this. So I'm going to make 2 sets of parentheses because there's no GCF. I'm going to do 3m and m. And then I need to multiply by a 2 but get a negative 1 in the middle. So that's going to work if I put a 2 and then a 1 here. And to get a negative 1m in the middle, if I have a minus 1 and a plus 2, let's see if that works. We'll have a 3m squared minus 3m plus 2m gives us our minus m in the middle, and then we get a negative 2. But notice none of these factors were close, but we don't have them matching perfectly, and no, they're not opposites. So nothing would cross out, so this would be our final answer.